your project also later. So you can practice, you can make the sample or the test the application for your project in local machine. But when you submit, when me and GA grade the project, we will the review the GCP instances also. So please create. I strongly suggest to create the MySQL instance on GCP. It's not very difficult. It's just several times click. Okay. Then the good news is whenever you feel that this is something wrong or if you want to restart, you can remove the instance and create again. Okay. And also try to connect and play with the database instance. This is not for public and not for other, only for you. So you can do whatever you want. So you can mess up, you can change it, any configuration. Please, that's the reason I decide to use. But it is some of the students complain. Why not using the local machine? But local machine is a very, very straightforward. You may not realize something issue of the connection, like the networking. In case your database in remotely is totally different. Okay, the local, their communication is usually based on probably if you are taking the operating system, we talk about the interprocess, the communication, IPC, which is mostly automatically the setup, the communication. You don't have to do a lot of job, but 99% of the database that you are going to encounter after graduation for your project is not on your local machine. It's on the remotely. The remote server is other database server. So if you do not understand such a configuration of the connection, it will be very hard sometimes, okay, to understand your overall architecture of your system. So please create the MySQL instance and practice with your own MySQL instances on the GCP. Okay, so today but on Wednesday we do not have the exercise lab. Instead, I'm going to have a lecture for I'm doing the lecture very fast. I think the 30% faster than usual. So which means because you are so smart, so I believe that you can understand my lecture, and also you are very diligent for your preview and review. Please read the textbook. Okay, do not rely on the PPT file and find a lot of the references and the internet source to understand the database, the database concept. Also, this time we are using the GCP, the cloud computing. So please understand the cloud computing environment for your study and everything. So today we are going to continue the mapping the ER model to the relational database model. Before that, I'd like to quickly summarize what we have discussed so far. So this one, this is a cloud. This is information that we are dealing with. This is our target to organize. However, this information, sometimes nowadays we can directly use such information to manage such a data in our computing environment, like the big data system or some NoSQL database. But still they need something organized. It's just the random. It's not organized like your room. Okay? So when you find something that you want, if your room is not organized, it's very hard. It takes a long time. Okay? So from time to time, you need to organize your room. So that organized room is called the database that we are going to eventually build. So this is our target. Database is running on the computer. Okay? This is a computer. Inside, we are using EBMS, Database Management System, like the MySQL. This computer, in this class, we are using the cloud computing. It's not big difference between your laptop and the GCP, the cloud. The only difference is somewhere. But as long as you are connected, you may not feel there's such a difference. So MySQL is one of the example, Oracle Informix DB2, SQL Server, and so on. Among them, we are using the MySQL database management system. Using DBMS, we can create the database. running on a computer. Okay, so our goal is then if we have, suppose that we have such a database, we are able to use the access this database from, like I'm using the C# or ASP.NET or the Perl, or I'm using the Python, PHP, whatever. Okay, the program language, you are able to access this one, then get the data, then we can have the application program. So combining this is called the database system. This is our goal in this class, to build such a database system. Then somebody may be curious. So when you access the data in the database, we can use the SQL language. It's a program language. This is another program language. But why do we need to use the two of them? SQL is only for accessing data in relational database management system. All the other, like the GUI or some complicated algorithm, you need to use this one. We will discuss more details about the programming environment in the database system. Yes, question?
Can I access, for example, using PHP from outside the GCP?
Oh, sure, anywhere. Okay, as long as you have the connection to the database.
So through the IP address, isn't it?
If you are using TCP/IP protocol, then you can use the IP address. Depending on what kind of the protocol you use for the network connection, it's various. Okay? But mostly we use the TCP/IP nowadays, which means, so for example, in your project, I create a MySQL database. In mine, the laptop, I'd like to connect. Or somewhere other, the GCP, the instance, I'd like to connect the data. You need to set up the network configuration, including the TCP/IP or the whatever. We will see the more details later. Okay. So then, to do that, from information to this one, first we cannot directly use the non-organized information to the database. It's totally different. Okay. It's totally different. So our goal is to get close to the distance. So first step is we apply the ER modeling. So logic, the conceptual database model, conceptual, or sometimes it's called the logical database model using ER modeling. So ER modeling is a data model, not database model. We don't know database yet. Okay, it's just to organize the information to make the data using entity and relationship. So this is one step close because it's organized. We combine entity, similar entity, then make the entity type. What we call the entity, like the student entity or teacher entity, and the teaching or register. So such a thing. So this is an ER model. So, but it's not very difficult. It's mostly used database data model. It's not only for the database, it can be used for many other software engineering or project, even non-computer science related project. They can use the ER model also. Think about the cleaning your room. So when you organize your room, you don't want to mix the operating system material, database material, then you don't want to mix that. Instead, I keep the only database. I only keep the operating system, then the organizer. So that is the idea of the entity and relationship. Then, also, this is still far from the DBMS. We cannot fit directly this one to the database. Instead, we discuss about the relational database model. The database model is almost close to the database system running on the computer, inside the computer. Okay, this one database model focus on how to how to organize such as data that fit to the database. So at the time we use a relational database model. Like we have relation and the primary key and the ID and there's a foreign key like this. So this is a relational database model. There are many other database model, network database model, object-oriented database model, and object relational database model, and so on. Among them, we decide to use relational database model. Relational database model is based on the definition of the concept of the relation. Relation means group of data. We consider data as a group because if we consider individually one by one, it's very, very expensive, and sometimes we cannot handle. When I have the 70, 80 students, if I can do that, I'd like to. But when I have the 1,000 students to advise, so I can take care only the GPA, minimum GPA for graduation, the requirement course. Not your individual situation like I'm sick and for this one and my friend is terrible condition I need to. So I cannot consider such an individual situation. Instead, the standardized, the only information for each student. Then that is the idea of the relational database model. We consider the data as a relation. Then we define the sum of the constraint, like the primary key constraint. Actually, the key constraint, key means the unique, and the entity integrity constraint, non-null. In case of the non-null and the unique, that is considered as the primary key. Because of that, even before you take this class, you heard about primary keys, non-null, and unique. So that is the primary key. And also referential integrity, in case the data, referencing data should be in the reference there. Right. So foreign key. Then so on. So this is a relational database model. So relational database model is very close to this one. So by defining the physical database model, like what's the size of this student relation? Sometimes we call the relation formal way, formal terminology. Informal, it's a table, column. So you can use both of them interchangeably. So it's not a big deal. So then, using this relational schema diagram, we can create the database. At the time, we need to specify the size of them and the specific data type and so on. So that is a physical database model. So we will learn a little bit more about such the things in using the SQL later. Okay. At that time, we need to use the SQL, even to access the data. To create the database, we need to use the structured query language. That is a part of the also relational database model. Okay. Especially this one, relational database model is a relational algebra, relational calculus. Again, the mathematical terminology, the algebra and relation again. So as I said, that's one of the reasons. So my major in my undergraduate was the mathematics education. So which means I'd like to be a high school math teacher, not computer science. Even though I took the only couple of a very basic level of the programming class at the time. It's 1989, 1990, Fortran and COBOL. So that's the only thing I learned until I got a job. So but I was the database administrator, DBA for Oracle database. So my supervisor, picked me up. The only reason is my major was mathematics. So he believed I can understand such a relational concept. So first year I usually study and took the class or the so actually database I studied by myself. I never took the class in the university and or the graduate school. Even during my PhD and master, it was that way. But so which means the SQL also based on the mathematics. So we will talk about the relational algebra, relational calculus in the next class on Wednesday. Okay? I know some of you guys already know about the SQL. Okay, but this SQL is based on the actually relational algebra. For example, if some of the students believe the SQL is very easy, I learned by myself within 10 minutes. So yes, you can do that, like the select from where, very simple query. But in real life, if you join the real project, some of the SQL is it's just a select from where, but takes the 2-3 page long. Okay, and it takes several days. But if you change one of the line, or one of the really the name, then its the response time is just 1 or 2 seconds. It's a huge change. Then, if you do not understand the relational algebra or such a basic fundamental of the SQL, sometimes it's very hard to understand why. Okay, so we will discuss the SQL based on this one. Then, however, still there are missing parts. Here, from the information to build the database, there is a still missing part. That is this part. So we did from information to the ER modeling. We did the relational the database model, the RDB to the RDBMS. So using the SQL, even though we don't discuss this part, we will cover later. But this part is still missed. So today we are going to discuss how to make the relational database schema diagram from ER diagram. In other words, ER diagram to the relational database model. Good news, it's very straightforward, very easy. It's just a step, follow the step 2A. Okay? If you understand both ER diagram and the relational schema diagram. So we will talk about this one today, and we will skip chapter 5, 6, 7, 8, the 3. That is actually discuss about the SQL, but I do better discuss this part first, then follow this step. So it's not a big deal, but unlike the textbook, we will talk about this one first. So our goal, objective of today's class is from this ER diagram. This is the ER diagram. This is an ER diagram, okay, that you're familiar with. Everybody, I believe in your mind you already. Oh, by the way, we had the homework, right? Last time. So please submit the homework before you leave, okay? So that it will be updated because last time I forgot to brought the homework again, but anyway, so submit the homework.
We don't have a printout of it.
I think that I asked you to hand in the handwriting of.
That we printed out and submitted to GA. That we printed out and submitted to GA last time.
GA, you already submitted?
Yeah, the ER diagram in tab.
Yeah, ER diagram. ER diagram, that was the last one. I assigned another homework last time. Yeah, the end of page, end of slide. So that's the homework that I assigned at the end of the class. Yeah, the chapter 5, end of slide, the answer. Okay, if you did, just submit it. So if you don't, so don't worry. It's not a big deal. Just consider as a small extra point. Okay, so this is the ER diagram, and this is the relational schema that ER diagram. However, I don't think it's a good idea to do homework right now. Okay, this is more important. Okay, worthwhile to pay attention to the lecture. Okay, so this is our goal. So today we are going to discuss how to map or convert this one into this one. Okay, that's a simple thing. Then to do that, please keep in mind this one. Okay, at least you need to keep in mind that this one. If you have the handout for chapter 3, so you can use this one. Okay, then first we are going to start the entity. For the entity, so in this part is the ER, this part is a relational model, database model. What will be entity? Entity will be table. That's simple. So we can convert entity to the table. For example, so we have the how many entities except the weak entity? We have the employee, and then we have a department, and we have the project, and we have weak entity, the dependent. So first we are going to convert each entity to the relational schema. Relation. Okay? Using the relational schema diagram, it's like this one. Then plus each attribute will be what? Columns or attribute. So for example, here we have the social security number. We have the B-date, birth date, address, salary, and sex, and so on. Okay, we can create the attribute. Single attribute. What if the composite attribute? Like for example, if we have the composite attribute like the name, first name, middle name initial, last name, we can create attribute for the terminal attribute. So for example, in this case, first name, middle name initial, last name, in case the composite attribute. What about the multi-valued one? Like the location of department, not this one, the department. We will take care later. Except the multi-valued one, we can convert this. One more thing is for each table, we need to decide what? What is the definition of a relation? Group of data, and it should follow the constraint, primary key. So we need to decide the primary key. When you have one key attribute, it's automatically you can select that as the same. However, what if you have the multiple? For example, department is the name is unique, and department number is also unique. Like the department, DPT, and this is an employee. And department, D name, D number, and we will take care of location later. This one, other information. So this is a key. This is also key attribute. How many primary key we can select? Only one of them. We need to decide one of them as a primary key. Is there any general rule? Either of them is fine as long as unique and non-null. However, it depends on functional analysis. If your system accesses the department frequently through the department ID, okay, then we'd better. Also, for example, the social security number, and let's say this is the EMP ID. Both of them are unique, so maybe key attribute. If you are using this table for just company management, employee ID is better because many of them are using employee ID, many of the applications. But if this one is for tax purpose, like the payroll, then we'd better select the social security number as a primary key. So you need to decide which one will be better. Either of them is fine, but you need to decide. So in this case, the D number, I'm going to select the D number. If there's no specific the reason you can find which one is better, which one will be better, number or the character?
Number.
Number is faster. Eventually, computer obviously convert the number any character into ASCII code or any number, then process it. So it takes longer time for the performance issue. So because of that, do you remember the surrogate key or artificial key when we talk about the union type? Like the owner, how many different superclasses? 3. Bank and finance and whatever. So they are different, so we create a surrogate key, owner ID. Similarly, if there is the D name, so there's no D number. D name is unique, but name is like the 100 byte. Or sometimes you can have the composite key. Composite key is too big, too long. Instead, you can intentionally create the key, like the D number or something. That is the reason, before you take this class, if you already create a database using SQL Server, for example, customer table, customer ID, customer name, and so on, automatically you already use the ID for your primary key. First reason, it's unique. So that is true. And also, it's fast. So is it always the best way to create such an ID number, surrogate at such a unique for the primary key? Is it the best idea? So always good solution to create the ID?
Yes.
Yes? What do you think? Depends. Right. It depends. For example, when you create the key, like for example, I have the transaction table. So you probably want the transaction ID. How many process can access this table? Many. So like a lot of branching. So you assign the 100 for this transaction. Next, this one, 101. Next, this one, 102. What if this one is revoked? Cancel the transaction. Is there any 100? No. So it depends on your policy. Okay. So if your policy does not allow the skip jump of the ID number, okay, you should use the different way. Also, sometimes, what will be the next number? How do you know that? How do you know the next number? That's the overhead. You need to always manage last number, biggest number. Then also think about the multiple, synchronization issue. Some of the DBMS provide to create the sequence number. Like the Oracle provide to create the sequence. So then you can actually get the next unique number. You can also skip the certain number depending on the business rule. But it's always overhead. Managing the sequence number is not cheap. It's expensive and sometimes complicated. So because of it, not always the ID number is the best solution. Instead, you'd better have the composite key or other key. So you guys need to decide which one will be the primary key, best way of the primary key. Then we have what? The project. So we have project. In case of a project, so we also have the P number and P look. Where's the project? P number and P name and location. This one is the single value location. Then we decide to use the P number. Okay? Yes.
What about in the department? We have multi-valued location.
So as I said, we will take care of the multi-valued one later. Okay, I will explain the why later. Yes.
What if we have more than one composite attribute?
The composite attribute, which means this one, composite attribute. Yes. So we can create this one and this one for each column. Then if you have another composite, like this, another column, separately. Okay? You don't have to create the name. So one of the best example is the address. Okay? So address, if you are going to get the input separated, CD name or the street name and state, you'd better create the column for each. However, if you just use the full address as your data, you never use the separated CD name or whatever, you can keep the only address, create the table, okay? One table, one column for the address. It's up to you. You need to decide. There's the rule. So that is the reason. Understanding the modeling and design is easy, but practically it needs a lot of the experience to decide such a thing. Okay, so that is what is this as an example. So we can convert the entity into the table with attribute plus primary key, always a primary key. I never create the primary key when I create the table. What happened?
You cannot access between another table. You cannot create a relationship without duplicate.
That means that's not relational database. That's just a bag of data. It's called a bag of data. It's a collection of just the data. It's not database model. DBMS, like the SQL Server, Oracle, they allow without the table, without primary key. That doesn't mean that you do, but sometimes it will be hard to manage. You cannot find the exact data. Okay, that's not relational. However, the commercial DBMS, they try to provide more flexible the functionality. Because of that, they allow the table without primary key. However, in terms of the relational model, you need to. Otherwise, it will be huge housekeeping job later. Okay, so that is the first step. So let's take a look at the example from here. So first step is we are going to create the table for regular entity, strong entity here. Then decide the primary key and so on. Okay. So next one is the weak entity. We have the weak entity here. The characteristic of the weak entity is what? It does not have the key attribute, only partial attribute. So it has what? Identify relationship. So in this case, however, if we create the dependent, so name, sex, birthday, and relationship. So there's no primary key. So at that time we can use identify relationship to make the primary unique key attribute of this one. This actually employee. So employee SSN primary key will be used for the part of primary key of weak entity, which means we are going to add SSN. To differentiate from the SSN in employee, we can say ESSN. It doesn't matter. I will talk about such a naming rule later. Okay. So at this time, primary key is connected line of this. If you are using the only ESSN as a primary key of dependent, what